Good afternoon, everyone. I'm Steve Tucker, NACAT board member. Want to thank everyone for attending our afternoon seminar on ADAS. Just a couple items before we get started. You are all muted, so any questions that you might have will be addressed at the end. Just put them in the chat box, and Rick Martineau and I are going to ask them at the end. Also, you'll be getting a certificate at the end of the session that will be automatically generated and emailed to you. So moving along, on behalf of NACAT, I want to thank Scott Brown for being our presenter this afternoon. Scott has been an industry leader for over 35 years. He and his wife own Connie and Dick's Auto Service Center, which has been in business for 60 years. Scott's an ASE Master Tech with a specialty in engine performance and electronics. Scott is also past president of IATN, serves on the NASTEP board of directors, and is the founder of the Diagnostic Network. There's a link in Scott's bio on the website, and you might want to take a look at that. So on behalf of NACAT and our participants, I want to thank you again, Scott, and I'm going to turn it over to you.
Great, thank you, Steve, for that introduction. And I'm pleased to be here participating in the NACAT virtual conference. Let's see, I'm going to get my screen up here, and just want to confirm you should be able to see my screen. Okay. So this is great to be back at NACAT again. I haven't been to a NACAT event in the last few years, but I've had the pleasure of presenting, and I'm very happy to be presenting here. This is an introduction to ADAS service. This is a class that I've been teaching with on behalf of AES Wave. They have clients that are buying equipment, and we're giving them a hands-on training in our facility here in Southern California. So this will be an abbreviated presentation talking about ADAS service, but also an introduction to what this technology is, what's actually going on behind the curtain. So I hope to be able to share a lot with you. So what is driving the ADAS stuff? Of course, you know, it's bringing a level of safety into the vehicle, but are these systems are also complying with certain safety standards. So I find that it's interesting, or it's useful to understand where these safety standards come from. And so there are two of them here. One of them is the automotive safety integrity level. This is like a self-certified level. And then there's ISO 26262. These two kind of pair up with each other and work in union. So the ASIL standard basically goes from A all the way up to D. You know, it's the social acceptable hazard severity. So sometimes you'll see components or systems, and they'll have ASIL ratings, and it's good to know what that is, because there are a lot of questions about who's liable for what. You know, if I'm putting the system back into service and it doesn't behave properly, you know, what is going on here? So we're going to talk a lot about this here down the road. And then ISO 262, you know, classifies the required functionality of safety and electrical systems via those levels. So GM published a college or university did a study on behalf of GM, and they published in July of 2019 a study that they ran on 3.7 million vehicles, covering 15 safety systems, and these are on GM's 2013 to 2017 model years. And you can see that this stuff actually works. It is basically, if you look at the forward automatic braking with forward collision alert, 46% reduction in those events. And then if you go to the lower right there, you've got 81% reduction in backing crashes. So I'm sure that a lot of the folks in the room have been driving a system out there that has had some sort of alert to let them know that, hey, you're about to have an incident, and you know, you woke up or paid attention, and it helped you avoid a tragedy. So the other thing that might be interesting for you to understand is, what are these SAE levels? SAE has a J3016. They've identified 6 different levels, And so, we started with level 0. Those are primarily just warning indicators, but they may actually have some sort of interaction with the vehicle, where it's automatic emergency braking, or what have you. But as we get into level 1 and level 2, and this is where we live in today, and I think we're going to continue to live in this period for quite some time, because when you get up into the right level, the level 3, 4, and 5, this is where these systems are tasked with some pretty high orders to keep that vehicle safe. And when you get up into level 4 and 5, you may or may not have controls in the vehicle. This is where you're going to have a lot of liability, and you have to make sure that you're solid with your processes in doing services. The biggest issue that I see personally, from my personal opinion, is that there is a huge amount of marketing to the general public about what these systems really aren't, right? So if you look at this ProPilot picture, this is just a screenshot that I took of my TV in my living room. And you look at this thing, and during the commercial, and I have another commercial I'm going to show you here, but you see this lane being blessed with this nice blue oasis. But if you look down at the bottom there, it says, ProPilot Assist cannot prevent collisions. It's the driver's responsibility to be in control of the vehicle at all times, always monitor traffic conditions, and keep both hands on the steering wheel. System it operates only when lane markings are detected. So if you think about this language here, this language went through the highest level of legal from the OEM to be published. So you think about that for a minute. Hey, if that lane system is not working right or whatever, it's probably due, or it could be due to the infrastructure itself. And we'll talk a little bit about that as well. Here's another commercial from Ford. Driver assist technology are supplemental. Do not replace the driver's attention to judgment and or need to control the vehicle. And then this one I found kind of interesting from a technical standpoint. The Super Cruise, if you look at the fine print there, it says, always pay attention. And then it says, visit CadillacSuperCruise.com for compatible highways, but it requires an active OnStar plan, active Wi-Fi hotspot, working electrical system, cell reception, and a GPS signal. So there's a lot of points of failure there that would prevent these systems from working 100%. So, and by the way, I'm going at a pretty fast pace. Please submit the questions that you have. I want to try to hit these at the end, but we're cramming a lot of material into a very short period of time. So this is talking about Tesla. Tesla, if you haven't had a chance to drive a Tesla, I would highly recommend you get some seat time. I'm confessing here that I have had a Tesla Model 3. That is my Model 3. I've had it now for 1.5 years, and just absolutely amazing vehicle. I rent a lot of cars, and we do a lot of instruction here. And I've rented some Highline cars, and their systems are way behind what the capability of this car is. But this system here, it says it's using the NVIDIA autopilot computer, and it can handle 12 camera inputs. It's running multi-layer neural networks, and it's just absolutely amazing. But this is actually old. Today, Tesla is now releasing their cars ever since April of 2019. All the vehicles now have their 3.0 self-drive computer. And this is the unit here. And this was all released at a live event, and it's fully recorded on the Tesla YouTube channel. It's about 3 hours worth of material, highly informative. I've watched this presentation probably 3 times. They've got engineers that give full-on presentations into what these systems are doing, very informative. But this is that module here. This is their new self-drive computer. They've got 2 full self-driving chips. They're interdependent, meaning one can fail, the other one can just pick up and go. 250 million gates and 6 billion transistors. And this is some stats that I pulled from that presentation. The capabilities, the bandwidth that it can handle is 2 terabytes per second. The image processing power today in that new module is 21 times greater than the module that's actually in my car. Frame rate, they gave an example there in frame rates. It can handle 2,300 frames per second versus 110 frames per second. 144 trillion operations per second, 80% of the cost. So they built this thing from the ground up for just their solution, and they were able to do it for 80% less than what they were buying from NVIDIA, because NVIDIA was building a kind of a universal setup, because there are other customers out there, Mercedes, BMW, that would also use their drive computer and utilize other functions. So they built their system from the ground up. They are working on version 4.0 today, so it'll be amazing to see what they're going to be able to do. And they all pretty much have HDR cameras, and we'll talk a little bit about HDR. Here's another stat, which is kind of it really struck me when I read this, but in October of 2016, GM published this document on their next generation digital platform. And it says here that they can manage, their system can manage up to 4.5 terabytes of data processing per hour. And I thought, per hour, what the heck is that? Well, how does that stand up? Tesla, 2 terabytes per second. That's actually about 1,250 megabytes per second for GM. So pretty amazing. So a little bit more about the Tesla. It doesn't get it always right. And I've got some interesting video and examples here, but this is actually my car. And you can see the visual on the screen there. You can see that there's two bogies there. And let me grab a pointer here, a laser pointer. You can see the two bogies there. There's a white guy right there and then another white guy. Well, I'm cruising along in the carpool lane at a pretty good clip. The lane to the right is going at a slower clip. And all of a sudden my car just stops passing the vehicle on the right, because it thinks that that car is one that's either going to pass in my way or it's in my way or what have you. So the driver always has to pay attention to what's happening out there on the road. The other cool thing, and the Tesla, has over-the-air updates, so it's always getting updated software improvements. And this is something that came along probably about 6 or 8 months ago. And when you're at a higher rate of speed and the adjacent lane is a little slower, it's going to adjust that speed differential to a safe level, and it gives you an indication that it's actually carrying out that task. So how does all this stuff work? So it's using tons of inputs, just like we as humans do, to make decisions about what we're about to take action on. So it uses cameras, wheel speed sensors, radar, ultrasonic, steering angle. A lot of these sensors now have internal measurement units. Some of that data we don't actually get to see. You've got GPS, and you also have LiDAR that is coming into the mix. So here is actually an example of sensor fusion. And I'm hoping I can just turn the sound off here.
We cannot hear it anyway.
Okay, so here I'm driving this. This is another customer's car, and you can see what happened there. It basically, it's painting out objects that are in the road. This car actually has a 3.0 hardware in it, and it's using all of its inputs to understand the world around it. So it's using GPS, high resolution maps. It's looking at objects. It's classifying those. It's identifying the objects. It's classifying them, and so on. So what do I need to know about this as I move into the ADAS service? So if you're thinking about getting tooled up for it, well, you need to understand what your car park is. You need to understand what services you're doing and how they may be impacting any of these systems that may be on those vehicles in your car park. You need to have access to service information, and you need to probably have access to multiple pieces of service information. You need to have a deep understanding of the components, and then how those systems interact with each other. And then you need to develop some processes on how you're going to transact with the customer. So in the beginning, we talked about some liability things. I'm going to provide some recommended best practices, but of course, I'm not a lawyer. This is not legal advice. You need to consult your legal counsel. But what I highly recommend is that any language that you use, you try to leverage the owner's manual, service bulletins. Again, those are all the items that pass through the highest level of legal. They spend all the money to do that, so pivot off of that so that you can leverage that information. as stated in, that usually works pretty well. So all systems operating as defined in the owner's manual, operator manual, what have you. When you do documentation, you need to make sure that you are covering your butt. Perform wheel alignment as per service operation outlined in this document. A lot of wheel alignments require at least a steering angle reset. Some of them require a 0-point calibration. Some require lane camera or a radar calibration. So you need to be referencing your service information to understand what that vehicle actually needs to have done to it when you're done working on the car. So here's a couple of, these are some tables here on some recommended processes. So you've got, why is the car coming in? What's the service reason? Findings collision center, requests of wheel alignment, ADAS related services, and then, include some notes maybe to let that paperwork speak for itself. If you happen to end up in court or, service center end up in court or what have you, that paperwork really should paint a clear picture. Hopefully, if your paperwork paints a really clear picture and a lawyer starts looking at that, they're probably going to skip right over you and go on to the next low-hanging fruit on the tree out there. And again, more processing, four-wheel alignment, four-wheel adjustable, document what you did. I adjusted the thrust line to 0.01 from 0.29 or what have you. So document what you found as the requirement for each of the services and so on. So where can we find service information? There is a wealth of knowledge in owner's manuals. I found that they are more descriptive about how systems operate than the service manual is a lot of times. Frankly, the service manual just kind of is not very clear on how the system's supposed to work or what have you. So do yourself a favor, pick up these owner's manuals and start taking a look. A lot of them are online now. You can just quickly grab a PDF and start going through them. What I have found is that some of them have some really good information about driver assistance systems. You'll also understand how their acronyms are set up or what they're calling their various systems. And again, these systems, a lot of times their naming is in line with some of their marketing efforts to sell that vehicle or sell the features. So really a great point of reference. They talk about how the systems work, right? But more importantly, when the system doesn't work properly. The last thing you want to do is waste a bunch of time on a consumer complaint for a system operation that is normal, especially if you did some work on the car and now the customer comes back and says, hey, ever since you did this, it doesn't seem to be working right. So if you look here, it says lane change alert may not always alert the driver to vehicles in the next lane over, especially in wet conditions or when driving on sharp curves. The system does not need to be serviced. So very important to be aware of that. And you show that to the client and now you're off the hook for wasting a bunch of time. And it also talks, this one here, this is on a 2018 Cadillac, talks about the zones. Where are these zones? How are these zones supposed to work? And so on. A lot of really good reference information. Adaptive cruise control. It's these systems they actually work fairly well. But if you look here, it says read the entire section before using this system. A lot of rental cars I get, they have more than 6,000 miles on them, and I find owners manuals that are still in the shrink wrap. So people, they're just hop in the car and start driving. That's another good point of reference that if you did get hauled into court or something, get your attorney to find out when they actually read how the system worked and reviewed the service or the owner's manual. And again, more statements about how they don't work, right? Does not react to pedestrians, oncoming vehicles, stationary objects, and so on. So just a lot of really good reference information. This bit of information I thought was pretty useful. I've attended a lot of presentations over the last few years on driver assistance, and seen a lot of statements about how systems work. And One of them is always isolating each sensor. So in this case, we're talking about a radar and a forward-facing camera. A lot of times I hear statements about, oh, that camera is only used for lane keep assist or lane keeping or what have you. But if you look over on the right, it says here that you know, the auto emergency braking system with pedestrian detection uses a radar sensor located in front of the vehicle to measure the distance to the vehicle ahead in the same lane. For pedestrians, the AEB uses pedestrian detection systems, or I'm sorry, with a pedestrian detection system, uses a camera installed behind the windshield in addition to the radar sensor. So again, it's fusing that data and it's using multiple inputs and it's weighting that information and trying to understand the world around it and making decisions. Again, a lot of safety things. Failure to use proper care of injury may result in death or vehicle damage. So a lot of good stuff. So service information, tools, and equipment. You may think that there's a lot required, but I'll tell you right now, you don't need a whole lot of tools to do some of these services on certain vehicles. In this case here, I'm just looking at an adaptive cruise control operation on a 2015 Suburban. That radar sensor is up in the left frame rail. It may need to be removed when some service is being done to the car or what have you. But to put the thing back together and calibrate is not a big deal. But what I found interesting in this service information here is that if you have to replace one of these modules, even after you perform your calibration, it says here that performance of the ACC system may be degraded after a cruise control vehicle distance sensor module replacement. Normal vehicle driving will correct the performance of the ACC system. So you're going to see some more information here from other manufacturers telling you that you need to inform the consumer that there is adaptation that needs to take place after you've completed the service procedure. But on this particular Suburban, this is what's required to actually do the calibration on it. You've got to make sure that the vehicle's on level ground, tires are all aired up, and you're just putting a level against that thing and adjusting it to level. And then the next step is using a scan tool to initiate an adaptive event, and you drive it down the road until it's complete. Pretty cool. So no real special tools. You can go down to Lowe's or Home Depot and get your level. But a word of caution here, levels are not always level. You want to double check your calibration, especially if you're using digital levels. There's usually a calibration process. And if you're in a building that's been built by somebody that knows what they're doing, you're going to find 90-degree angles all over the place that you can use to verify calibration. In this bit of information I found interesting here is that this is for a Cadillac to aim the radar. And again, you're just using a level. And it says here that the digital angle gauge must have an accuracy of plus or minus 0.5 degrees. And it says the vertical position of a forward range sensor is 90 degrees plus or minus 3 degrees. Okay, so they're giving you a 3-degree sweep on that. They are actually 6 degrees, right? So plus 3 or minus 3. But what I found interesting further in the information is that it says, one, calibration is not required if the module was just programmed. So if it just had to be updated, you don't really need to do a calibration. Calibration needs to be conducted if the module was replaced or removed and resecured. But look down there at the lower part here, it says brackets out of level more than 2 degrees will not calibrate or self-learn. So it said plus or minus 3 degrees, but here you've got to be 2 degrees. So the rule of thumb, take it to 0, right? Again, and if you read in there, and some of the service information actually has troubleshooting steps to help you figure out when things go wrong, and they will go wrong. And that's probably another point of reference to maybe study up on, even before you start doing any of these calibrations, is start looking in the section where it says, what if it doesn't work? So in this case, if calibration is not successful, it could be due to improper driving environment, module, bracket assembly bent, a whole host of things here. So a lot of really good information to read up on in these systems. But again, the digital angle gauge must have an accuracy of 0.5 degrees. So you need to check your equipment frequently. In some service information, there are procedures, and in fact, in Nissan here, you've got what's called action test work procedures. These are pretty good. And again, if you're putting a system back into service and you need to make sure that this system is working properly, you need to document, hey, I performed the work action test procedure for the lane departure warning. And here it says check lane departure system. Start the engine, check that the lane departure system setting can be enabled, disabled in the display, and then turn the ignition switch off for 30 seconds, and then turn the key back on and make sure that the previous setting you had set is correct. So those are important steps, because there could be something that happened to a module. The vehicle could have been in a collision event, or there could be a power supply problem that has a deficiency, and it may not pass this test. But you certainly don't want to turn this back out into the world without verifying that these systems are operating properly. Targets. Talking about targets, a lot of guys are really looking at what does it take to do this stuff. And in the early days when these systems were first rolled out, the service information was published, the OEM manufacturer rolled these out to the dealer, and now the dealer is getting instructions here on how to make their jig, right? And they're basically just given templates and instructions on how to print out black and white paper and how to tape all this to a piece of cardboard and then make up a stand or what have you. There are a lot of companies out there selling targets. Some of them are building pieces of equipment that really help you streamline that operation and standing up this target. I would like to point out the fact that it's frustrating to see that you've got maybe the same manufacturer and two different car lines within that manufacturer that may require different types of calibration, even though the camera may be coming from the same vendor. And a lot of times those are driven by whoever was in charge of that, building that particular car line and the specs that they pulled up. I did find I participated in a lot of different ADAS groups, and in one that I'm participating with in the Auto Care Association, who's looking at trying to add some normalization to all of this, is that through the IIHS, which is the Institute for Highway Insurance, they were working with Mazda, and Mazda was very frustrated because their dealers, it's taking 5 to 8 hours for these guys to do a full calibration on a vehicle with these targets. I can tell you that recently we had a late model Mazda that we rented for class, and they're now giving two options: a static calibration and a dynamic calibration. So which one are you going to pick? Do the dynamic and take it out and follow the procedures out on the road here. But here you're taping all this stuff together, 120 millimeter squares, and then you're setting up these targets and placing them in the right position. This is a Nissan. Looks pretty similar to what we saw with the Mazda, right? Same size of the squares are the same, but the height and the placement of these targets are going to be a little bit different. Also, back in the service information, looking at BMW, for instance, they give you a single button to just turn this stuff off. In most cars, you have to turn each individual system off, but because BMW, I believe the reason for this is because they are the ultimate driving machine. Their consumers probably just want to hit one button and then just be in total control. But what I found interesting, again, in a procedure for the camera system on a BMW, is that here in this warning, it says the calibration process of this camera is not complete until the vehicle drives in traffic. Tell the customer that some assistance systems are temporarily unavailable after vehicle pickup. Wow, that's pretty bold. It's I don't know if I was a consumer, I'm not sure how I would react to that if they, say it was in a collision and they did all their work and then they just handed it back to me and said, here, go drive the car. Everything should start working better down the road. All right, so let's switch over to talking a little bit about windshields. A lot of windshields get broken out there, and just talking about some language. And you may not have run into this before, but I have worked with some folks, and I found that this is fairly, this is actually happening where people are interchanging processes. And so we're talking about programming and calibration, okay? Reprogramming, programming, what have you. So if you look here, you got big, bold, following replacement of windshield, but if you go up above this, two bullets above, says if the windshield was replaced, the front view camera module must be calibrated. The next one says if the front view camera module was removed and reinstalled, no action is necessary. Okay, and then now you go below that and it says following replacement of a windshield. Do not reprogram the front view camera module only when the windshield is replaced unless directed by a service procedure. So think about a technician that's in maybe a flat rate environment, which is really not a good environment when you're doing calibration like this or service work. But does he look at this and go, well, I don't need to really do anything to this car, right? Because it says following the windshield replacement, do not reprogram. It only needs to be done if the windshield, it's bizarre. But nevertheless, it is the reprogramming of a module is reprogramming the firmware or software or whatever. But calibration is another process. That is a process that you're doing. So again, that's I've had a lot of students in our class and they look at this and they go, well, we don't have to do anything to this car. So that's not correct. Some of these are very difficult. They have some pretty tight constraints on how you go about doing a calibration. So in this one here, you're talking about the central vision processing module, talking about it, reprogramming it. But to run the routine down here at the bottom, it says all exterior mirrors must be fully extended. Vehicle will need to be driven between 3 and 11 kilometers per hour. In a straight line. So, you're gonna have to go out and find a parking lot somewhere that's, negative a bunch of traffic and try to get this thing aligned. So a lot of work. So let's talk a little bit about cameras here and what they're actually doing and what they're actually looking at. So camera vision is pretty amazing. I've been doing photography for decades and this stuff is just fascinating to me on what they're able to do with machine vision, camera vision, what have you. But they're looking at text. So we've heard of OCR, where it can read actual text. It's looking at lines and it looks at other stuff. So this is a screenshot from from the highway up in Michigan, and this is up in the area where they do a lot of self-drive study and what have you. This is on the I-75 test corridor. This is back in June of 2017. But if you look at that sign, this is what's also embedded in that sign, and this is what that camera can actually see. It sees a 2D barcode in there with a lot of information. So on this one here, I'm not sure if you can read it, but it says left lane closed 1 mile ahead. Move to the right lane when you can. And there's also some additional data, contrast, 13.4, background 17, angle minus 45. So think about the car in that particular lane. If it's already in the right lane, it says, oh, I'm in the right lane. I don't need to really worry about it. But if the car was in the left lane, it knows where it's at the current position, and then it needs to start factoring in how it's going to negotiate a lane change to the right and keep that car safe. So pretty cool stuff. More camera vision. These cameras, as mentioned earlier, a lot of them are using high dynamic range, which is you probably have seen this on your 4K TV where you're consuming content and they list out HDR. It's not high definition. This is high dynamic range, and what that means is that it's taking it's got so many steps between the black and the whites, and it can actually differentiate all of those shades in between and give itself a wider perspective. So this is an example of a picture demonstrating some sort of HDR using a stills camera. But again, these cameras are doing 40, 60, maybe 100 frames per second, all in real time doing this HDR rendering. And by the way, GM started using HDR in their forward-facing camera on cars for level 0 systems in 2012. But in this picture, you can see top left is kind of an overexposed image. To the right is a normal exposed image, a normal balance. lower left is a super dark image, and then in the right, that's the eclectic mix of the best of everything. And you can see that that has a much broader dynamic range of vision. This is looking at some scopes here. This is a video scope demonstrating the scaling on camera vision. To the left is the standard or HD high definition, and it goes on the lighting scale here. You can see it goes from 0 to 120, and over on the right it goes from 0 to 10,000. So huge amount of resolution. Again, when the camera systems are working and they're using these neural networks, they've got a number of processes that they can take advantage of. This one happens to be called segmentation. And what it's doing is it's identifying the drivable space, and it's also identifying, vegetation and people as well. But they'll also mix that with other processes with the camera to help it understand the world around it and how to make decisions. This is a re-render or reassembly of some information from a Tesla. So this is looking at the just 6 of the cameras. The vehicle actually has 3 forward-facing cameras, all at different focal lengths. It has 2 in the B pillars, which are indicated here in the top left and top right. We're just looking at the real wide camera in the center here. And then on the left repeater, those are in the front fenders looking backwards. And those, by the way, are used for the blind spot. Tesla does not use a rear-facing radar on the Model 3 for blind spot. It's strictly cameras. And then you've got the rear, you got the main camera in the center and the bottom, and then you got the right repeater. This gentleman here that's assembling this data, he's a kind of a white hat hacker guy that I follow on Twitter. And he's logging all this data that's in the car, and he's reassembling all of it, and then illustrating what the system internally is doing to make decisions. And I've got a couple of demos showing a little bit more about this. This video came off of YouTube, and this is over in Europe, and it's looking at again from a Tesla. It's looking at how it's identifying things in the road. And I'm going to play this short segment, but if you look over as we go forward, if you look to the right, it will identify some people that are walking on a sidewalk with trees and other obstacles in between, and the camera is able to see that information. Let's play this. Come on, there we go. Whoops. We're going to go back one screen here. Okay, hopefully this is playing good for you guys. But you see the drivers, I'm sorry, the people in yellow bounding boxes, and it looks like this is not playing very good. I apologize, but look over on the right, you see the bounding box going around the people. Absolutely amazing stuff here. So this short little video here, and I'm going to show you a picture of this thing. I've got and this might help you with some instruction on illustrating what's going on. But you can buy from NVIDIA a Jetson Nano little project device, and you can get a camera with it, and you can download some a program off of GitHub, and you can run a object detection and classification program. And that's what I did with this little box. And I put it on the dash of my car, and I just drove around town here just north of my shop. And this is the program running, and it's driving along, and it's identifying vehicles. You can see the percentage, that's a confidence level that it's identifying things. You can see people on the right. This is what's going on, and this is only running, this is booting off of a small little micro SD card running on a little tiny module. And so you can see the people that are walking across the crosswalk. It's identifying the people, it's tracking them, tracking cars. So there's a lot going on behind the scenes on these systems to help them understand the road or the world around them. This is again back to the gentleman that I follow. This is from his Tesla. Now, there's a car that's going to jet across the street here, and he's going to swerve around it. But just make some observations about what you see in the scene. You see the dots. Those dots are actually radar returns, and that's how they're helping to identify targets. But look at it's identifying vehicles that are parked in a parking lot off the road and doing a pretty good job of labeling them. And you'll see the type of vehicle that it's showing. It says minivan over there. It gives a distance. There's the car cutting across. And I apologize. This video is probably not feeding very well to you as attendees, and just due to the limitations of remote presenting. So I'm sorry about that. Here's another one that I recently acquired from the same gentleman, and he's given me permission to use these videos. But this one here, this car actually did an auto brake, and if you look to the lower right, you see the vehicle speed. On the top of that bar there, you see where it's got a little bit of red. That means the car is accelerating. If it goes to the left, it's actually it's regenning, and then you'll see a red bar there somewhere where the brakes are being applied. But as we play this along here, you see the car is cutting over, and it's doing fine with that one. Another car that's cutting in, and it hit the brakes, and it brought the vehicle to a stop while the guy was driving. So these systems aren't 100% yet. I think it's going to be a long time before we get to the point where these systems are doing, they're able to do or carry out these tasks that the human is doing. So one of a new tool that I recently acquired is the stereo vision. So we've seen stereo vision primarily on Subarus. That's a pretty common view. You can also see those on some Mercedes vehicles out there. But with stereo vision, there's a lot that can be done with that. And in fact, Subaru has basically avoided the use of a radar sensor to detect objects in their view. So, this particular picture, I have some recordings here that I'm going to show. I've got this thing rigged up inside of my Tesla Model 3, and you can see the picture on the top left is actually the view that's coming just from the left eye or the left camera. And then in the lower left, it's doing some edge detection, and it's developing confidence around what these items, these edges and everything that it's creating. And then over on the right, that is a real-time 3D point cloud that is being generated to help the device understand where items are in actual Z space. Pretty amazing stuff here. So right now I'm gonna take us to we're gonna look at a live picture. Okay. And this happens to be, we're not in, I'm at my shop, but I'm doing this inside my office, which I share with my wife. And you see she's not here today because I told her I have to use her office. But I'll just explain the scene here a little bit. You can also see that there's a trihedral over here where my mouse is, and then there's another trihedral here, which we're going to use another demo. And I'm just going to pause the screen here for a second here so it's not flickering. And over on the right, we're actually looking at the scene. Okay, and I'm going to zoom in, and we're going to actually see the camera. I would just want to show you what the camera looks like. You see it right there? That's the this is a Stereo Labs, their new stereo camera, and you can see that it's showing the trajectory from the left view, but this is the scene of the office. Okay, and if I zoom in, you can see that these objects are actually being placed in Z space. So as I roll this around, it's understanding where these objects are, in the Z space, so it can make decisions around where these items are. Pretty amazing stuff here. But this is something that you might be able to use in instruction as well to let the students understand a little bit more about what's going on with the camera, because these cameras, when you go to calibrate and do stuff, you're just hitting a button and magic's happening, and you're not even sure what the heck is going on there. This helps you understand, get in a deeper perspective as far as what's going on with the system. So let's I got to reposition this, get this set up for my next demo. Okay. All right, back to service information. There's a lot of times you see there may be translation errors or weird stuff happening, so you need to make sure your technicians or students are always vetting or always questioning what they're reading. This one here, it's talking a little bit about the camera range and it gives you some ideas on what's going on. But if you look here, it shows you the camera center line. A lot of them are not placed perfectly in the center of the vehicle. But if you look here, it says the difference between the center line of the vehicle and the center line of the camera is 63 millimeters or 1 inch. Well, which is it? Because those two are not the equal measurements. And then also to kind of give you some more understanding here, the camera center line is actually pitched downward, which is somewhat intuitive. I mean, you want the camera to kind of get a good perspective of what's going on with the road, but this gives you an idea of what the field of view is and what kind of, how that camera is normally positioned into the wheel. Most of the time even though we talked about stereo cameras, but most of these cars have just a single monocular camera, but they're doing some magic in the back end with their software to help them understand the three-dimensional stage here, space. So you've got what's called a vanishing point, and the vanishing point is basically the imaginary lines, or the lines where they would basically intersect if you're looking at a straight, with the road ahead of you or the image ahead of you projected on a flat screen. And they use that vanishing point to continuously update the vehicle or update the software so that it understands how the calibration on that camera should be, because it has to be able to compensate for various loads in the vehicle and the various pitch angle that's taking place on the varying roads, because you're not driving on a perfectly flat space. So again, some of this stuff, this is a 2017 Mazda truck, and this is right out of ALLDATA. This is a factory service information, and they give some good description on how the system is actually operating, how it's storing the vanishing point and comparing it to the previous calibration vanishing point, and then doing updates as well. And that might be a good exercise to do, is you do a calibration, you look at the data on the scan tool, take the car out for a drive it on different roads, and start to look at the adaptation or the numbers and see how they change. Again, trying to illustrate how the system is trying to take a 3D space and rationalize it up on a flat screen to understand three-dimensionally how the world works. Data sheets. A lot of these manufacturers that sell these products, they put their ads out there, or their data sheets, so that when engineers are tasked with acquiring hardware data, they know what the specs are. They can come and do some investigating. But what I wanted to point out here is that on this particular camera, look at the specs: horizontal field of view 50 degrees, vertical field of view 27 degrees up, 21 down. Aperture resolution 2.6 megapixel. So if you look at those dimensions, that's 2048 by 1280. That's greater than high definition, which is 1920 by 1080. And it is a high dynamic range. Frame rate 45 seconds. But if we go down here to the hardware accelerator, DNN, so that's a neural network that it's using. It's got a classifier, optical flow. So those are all the things that they would be able to leverage their neural network software to help it identify, things that are going on around the vehicle. But as I mentioned at the very beginning here about the safety levels, look at what this, it says it's certified, or its safety level is up to ASIL B. We start at A, we go to B. This camera is not going to be sufficient when we get up into the level 4 and 5 systems. When we go to do camera calibration, there's basically two things that are going on when the camera calibration is taking place. Some of them we have no control over, some we do. Basically, the two operations you're typically doing are, it's an intrinsic and an extrinsic. Intrinsic is basically the internals of the camera, the focal length, the lens, the distortion. Those are the focal length and the lens type and all that. That's already built in. But there's lens distortion. Usually you've got a wide angle camera and it's got a curve to it and the lines are not straight. And what do we need to do? We need to correct for that. I have been told by some colleagues that work at some pretty high-end companies that work with this stuff all the time. They tell me these cameras are not very good. These cameras are basically $10 cameras. That's what they're telling me. And the lenses are not very good. If you look at a film camera or a video camera, usually you've got pretty high-end cameras where that glass is ground and it's super precision. You are not getting that with these small cameras. So they know that the camera has some distortion and they can do correction in the software to straighten the lines out. And so the other element here is the external camera, the extrinsic, and it's how the camera sensor relates to the world around it. The azimuth, the distance, the pitch, the roll, the height, and so on. And so that's why we're using these black and white targets. These targets are helping the camera perform a calibration function. So this is a picture of a typical target. And in this case, I took a picture, I took it into a photography application, and I purposely applied the wrong camera calibration, or I'm sorry, wrong lens calibration. And you can see where it's distorted. You can see the horizontal line here has got a curve to it. The vertical line has a little bit of a curve to it. But this is what the camera would look at, once they're trusting the service individual to place the target exactly how it's being defined in the service information, and then it's entering into a calibration function, and it looks at that image and it decides what it needs to do to correct that function. And once that function's applied, then this is the result. It gets it turns that curved line into a straight line. And then this is typically what you're looking at from a camera calibration. This is actually in our shop where we set up for doing camera calibration, radar calibration, what have you. If you've got everything set up properly and your area is well lit, usually we'll have no problem. A lot of times they'll tell you, you got to remove distractions and other things in the background. You can see that I've got a pretty wide varying background back there. We've calibrated tons of cars, and we haven't had any challenges with that background causing any type of problem. When we first started doing this, we did run into some problems, but it was our error because we were not paying attention to the service information. We were missing a step, or we weren't reading the distances properly, or what have you. So a lot of the pain for me has been self-inflicted, and a lot of it can be avoided if you just take your time, read the service information, and follow the process. This is just an image of, this is what movie studios do when they calibrate their cameras. Same type principle. They're using these high contrast items. All right, so we talked a little bit about when we saw that Nissan ad, it says only when lane markings are detected. I'm sure you guys have seen out on the highway that a lot of the lines now, the white lines are accompanied by two black lines. Those black lines are there to add the contrast, to bring that confidence level up so that these cameras can work. But if you look at the lower picture here, you can see that the calibration on the machine that was putting the lines down was out of order. And you can see that the black line has got a huge gap on the left side of the white line. So again, when lane markings are detected, that's dependent on a lot of variables here. And again, I mentioned that the tooling needed. A lot of times you don't need a whole lot of equipment to do calibration, depending on the car lines that you're working on. In this particular case, this is on a Chevrolet Volt forward-facing camera. We're using an aftermarket scan tool here, but the factory tool basically does the same thing. It is a dynamic calibration. Service information tells you to do all these things. Make sure the windshield's clean, make sure the camera's installed properly, tire pressures are right, make sure the fuel tank's full. So you're prepping the vehicle, putting the vehicle at the right conditions, and then you're going to drive the car in an environment to get it to learn. And it gives you some more information about what's happening, but it's a pretty quick process. And it says that learning process will take about 5 minutes, and it usually does, but it's also dependent on infrastructure. We have some roads around here where the lines are real crappy. Not a lot of contrast. You find a good road, and that happens pretty quickly. But you just drive along, and it gives you a little progress bar, and away you go. You're done and ready to go. When you do get to when you're doing this process, this is a good time to actually take a screenshot of this of the completion, so that you can then document it. That you perform that task. Usually the file will have enough metadata in it to also help you stand up in court with time and date stamps and so on. OEM tools, a lot of the OEM tools do a great job, and sometimes they don't do a great job. I'll tell you, there are times where you're going to need an OEM tool. There are times when you're going to need an aftermarket tool to pick up where the OEM tool falls short. And I've got a case right here. This particular car was a 2020 Ranger that we had in here doing some testing on, and this is using the latest. This is Ford's tool, and it's leaving me for a second here, but it's their latest system. And it basically, you download the tests from their site, and it runs it, and it tells you what you need to do. But it's also a dynamic calibration. But on this particular car, when I went to run the calibration, it asked me to run the, I'm going to scroll up here. It asked me to, right here, measure the wheel arcs. Okay, so I measured the wheel arcs in this rental car that I had. Those numbers were not what was on the car. So I went ahead and went through the process of, I go, okay, well, I'm going to just have to change them. They were only off by a couple millimeters. So I went to change them, and see if I have that recorded in this. It may not. Oh yeah. Okay. So I'm entering in the new number. Okay, in millimeters as it's dictating, and let me play it. And it's not showing the text on the screen there, but it kept failing. It would not do it. It would not take the data. So what did I do? I grabbed the aftermarket tool. I went into the process. I entered the numbers. It entered into its adaptive test mode. I took the car out and drove it, and it completed the process. I brought it back in. I then connected the Ford FDRS back up to it, went back into this process, and I can see that the new values were in there. Okay, so I thought, well, maybe it just didn't like those other values. So I repeated the process. I tried to enter the original values that the car came in with. It still refused to take that information. So, again, you may run into conditions where, even the OEM doesn't have their software bug-free. We live in a software world, and we're gonna run into challenges. On these cameras, there may be conditions where you need to do some diagnostics on cameras. You've got coax typically running these cameras. Sometimes the cameras are just a pair of wires, but if they're coax, you need to be able to access cleanly so that you can check and see if there's a circuit problem. A car may have been in a collision, or in some cases, like I've found here, the harness goes through the trunk harness, right? And that trunk duty cycle, it gets cycled so many times, and then there may be a break in it or what have you. And so you need a way to get into that circuit to do some validation. And you may want to also consider start looking at these signals with the scope. I have found that you can set up some triggers and get a decent scope pattern on your scope and understand a little bit about what the output should look like on these vehicles. We're also now starting to see cameras and radar sensors being combined, and primary reason, cost effective and reduced service costs. So you see I've got that underline there. So this Raycam here, this is one that's being used on Chryslers, late model Chryslers. The radar sensor and the camera is up in front of the rear view mirror. And it's actually probably a good move because that radar sensor, as we'll see here in just a little bit, is very delicate. And when it's up in the front of that vehicle, it's in a pretty harsh environment. So you can see on this one here, in that picture, there's a laser that's up against that radar sensor, and that's where that thing is mounted. But what are these radar sensors looking at, and what do they do? They're kind of they're in most cases they're a dual range sensor, so they have a short range function and they have a long range function. And there's a location on that Dodge Ram. Another thing you can do is also take a heat gun, and a lot of these have heater elements on them, and you can get a pretty quick assessment of whether or not the thing's powered up and working properly by using a heat gun. This is a field of view that you're typically looking at. This is off of a patent sheet that kind of shows what the radar looks like. But again, when you're in the car and doing functions and hitting buttons, you can't really see much data. You get to see distance, and you might get to see a range of distance to target, or rate of change and speed, or Doppler. And some of these are a little confusing. You don't have a real good visual, but I found a tool that's pretty cool here. And this is the Texas Instruments radar box, and I'm going to go ahead and pull that up right now. And then I'm going to pull up a camera here so you guys can see. And I need to get rid of this here. So we are looking at a live picture. This lower left here, this is our, I'll call it the baseball field. You can see that there's an object right there. It's right on that center line there, and there's an object to the right here. And those are the two trihedrals here. You see that trihedral there that's on top of that desk? And then there's another trihedral down here, down lower, that I've got in place. And so I'm gonna walk around here, and I'm gonna show you. As I walk into the scene, it starts picking me up, of course, but this is our trihedral right here. So when you're doing a calibration on a vehicle, you're typically defining the center line of that vehicle, and that would be where the radar sensor may or may not be mounted center line of the vehicle. But for this example, we'll assume it's the center of the vehicle. And then it's asking you to put that target a specific distance away and a specific distance up. And then once you do that, then you're hitting a button to let it calibrate so that you're giving it a baseline. So let me just show you what this little sensor looks like. And I have to hit the live.
Just a quick thing. We can see the movement on the plotter, but the camera is still.
Say that again? I'm sorry.
We could see your movement on the plot, but your camera was captured still.
Yeah, I had it in the still mode. There we go. We're live again. Okay, I'm taking my headset off because it won't stretch that far. So here we go. All right. So I want to show you what this little demo board looks like here. So you see the little board? You can acquire that. That's called a 1642 boost. All you need to do is go to Texas Instruments website, ti.com, look for automotive radar, and then they have evaluation modules that you can buy. This one, it does not do any elevation. It's not non-elevation, but it's pretty useful for demonstrating a couple of things here. So as you move around, you can kind of see me moving around in the scene here. So we can see where that's actually happening. System doesn't know where it is as far as height goes. It knows what the strength is. If you look to the right here, you can see the actual return strength of the two trihedrals there, okay? But if we go down the page, we're now looking at a Doppler plot. Get this thing centered here, okay? So let's get my camera so you can see me moving around here. So we got two objects there that are on the 0 line, so there's no movement, no movement in time. So you've got meters per second. And so as I'm moving in, so as I move away, you've got a positive number, okay? And you can see this, usually it'll give you a scan data parameter that will let you know what this is. It's a relative speed typically. But as you know, you're closing in, and you can see there's a lot of bouncing on, and I can see my computer is kind of straining there a little bit. This is usually running very, very quickly. But this will give you an idea of what Doppler looks like. You can see the rate of change and so on. And it might be a good experiment for you to have in a classroom, in the shop environment, to help your students understand a little bit more about what these radar sensors are looking at. Okay, moving along, we're going real quick. So here's a radar sensor out of a vehicle that went bad after a collision. We replaced it, but this one has elevation. So you can see we've got 4 transmitters, and the way these work, basically, you're on a flat plane here. These 2 transmitters are specific distance apart from each other. These 2 are closer to each other. You can see as we move from the center out, we get smaller. And then these are the receivers over here. So it's basically using triangulation. So it sends out, and these things are working at 80 gigahertz. So that's billion times per second. And it's sending out chirps that have a signature on them, and they specifically come back and they identify them, and they're doing this stuff in real time. So it's pretty amazing what these sensors are doing, but they're very delicate units. And so try to play this video. This is another video of, we're gonna not play that video. We're gonna try to play this one here. This is one that actually had a false indicator from the shadows on that bridge. This car was going at 80 miles an hour, and it quickly decelerated down to 70 because it didn't like what was going on. So you can see in this particular case, I got a screenshot of it. You can see all the returns, and it has all these stationary objects from the shadow from this thing. So again, do you think that all came from the radar? No, that was probably camera input, and it basically used that sensor fusion to come up with the wrong conclusion. Crazy. So what else can affect radar? Bumper stickers, all kinds of stuff. Well, here's a OEM test mule that I just saw out on the road there one day, and I came up close to it, and I saw that they had sliced out the wrap, so it was not affecting the blind spot monitor. So you know that you're not supposed to be doing that. Here's a radar sensor that came out of a late model BMW that was at a dealer. They could not get it to calibrate. It wouldn't calibrate. They finally had to just make a call on putting the sensor on. Which they did, and it calibrated right away. So this was under warranty, but they got permission to take it apart. And you can see that this little shield right here has an extreme dent on it. This thing got smacked, but there's really no damage to it. It just had such a huge shock wave that it actually created enough damage that it probably fractured something inside the board there, created a problem. So here's another video that shows how GPS is involved. So this is just north of Los Angeles, and it says that autopilot is not going to be available in 200 feet. Autopilot went into the lane tracking mode only, and you'll see that as I exit under the bridge and come back out in view of satellites, it goes right back into the nav autopilot pretty amazing that that stuff's going on. Ultrasonic sensors are pretty simple. One way to check and see if they're actually working is on late model cars. I found that they do generate some heat, so it's easy to check. But we just had a car in here this morning, an older Nissan. It had a sensor that wasn't plugged in, and we could not get a heat signature out of it. But the easiest way to check these is just use your listening stethoscope. Take the little pointer thing off the end and just use the hose and put it right over the front of that sensor. You'll hear the chirps. Okay. Here's something here that I just recently ran into. You will soon be required to have security credentials, and this is a NASTF deal. You're going to need to have a vehicle security professional or SDRM license to gain access to security functions. This car here, this is a 2020 Ranger. I went in to try to do the camera calibration and was told that I did not have access because I'm going to go to the next screen here. We won't be able to play this video here, but it asks you to enter your NASTF credentials because now they have to open up this bus to gain access to that particular system. Here's a quick case study on a vehicle that I had last year. I took one of my technicians here from the shop. We went to a training session back in North Carolina at a gentleman by the name of David Friend. He has a shop called Mobile Tech, and they were doing ADAS instruction. So we were asked to rent a car that had ADAS stuff on it. So I rented this 2019 Altima, had 6,600 miles on it, and we took it away from the airport and had an interesting experience. But I'll see if this works here. This is a commercial, but watch what happens here when she presses the button. Might not. So as soon as the actual wording there says it'll help you move the world and create your own lane, and they showed her pushing the button. The lane, the traffic moved out of the way, and she took her hands off the wheel. And I cannot believe that these OEMs are doing this marketing. It's absolutely crazy. But anyways, what happened here is that we're driving along in this rental car, and it's doing its thing. It's doing adaptive cruise control. Everything's working fine. It's slowing down. We actually got into stop and go traffic at one point, and it was just doing its chauffeur type mode. I'm thinking, wow, this is pretty cool. Finally, the traffic kind of eased up, and we got up to a pretty high rate of speed, 60, 70 miles an hour. We're cruising along, and traffic started slowing down again, and this rental car was not slowing down. And I had to like jam on the brakes, and my technician that was with me, he goes, wow, that was weird. What the heck's going on there? And I thought, well, all right, nothing. We re-engaged the cruise again, and we're driving along, and this error message popped up, and it says front radar not available. Our front radar blocked. Okay, so I hit the button again, and it gives me this yellow indicator on the forward-facing area that's got a problem. So we pull over, shut the car off. I look around, try to figure out what's going on with the car. We thought maybe a bag or something got over the front of it. We didn't see anything wrong. Started the car back up, and everything worked fine. Now, the key cycle, the system started working again, but it failed again. So that next day, we ended up in the class. I told my instructor, I said, hey, we've got a vehicle that actually has a problem, so let's check it out. So we went and scanned it, and we found this C1A 16-97, a radar stain. This code is actually kind of common. I've scanned a lot of these cars, rental cars, and it seems to be a pretty common thing here. But after key cycle, as I mentioned, it goes right back into normal operating mode. But in the service information, it says C1A 67 is a radar stain. That could be a language translation. But it says it may be detected under the following conditions. Explain to the customer about the difference between contamination detection and an indication when the malfunction is detected, and tell them this is not a malfunction. So there, in my assessment here, this is kind of a temporary thing. It's telling you it's temporarily blocked. It could be snow, or some other climate condition. But what we did in the class is we went ahead and started doing some inspection, and we found a problem. And as you can see, this is what we saw when we popped that front nameplate off of there. And if you look at the sensor, it's actually rotated backwards, and it's pointing up in the air about 30 degrees or so. Here is an image of the vehicle. I did a lot of experimenting and collecting some data when I had this, and you can see there's a higher profile vehicle in front of me, and it's picking it up just fine. Here's an image with about the same distance, and it does not see that vehicle. And that's because it's looking right over the top of the car. Here's a couple of images of what it looked like when we found it. We went ahead and bent it forward to a 90 degrees and performed calibration, and then drove the vehicle around. We all concluded that basically that this car had been in some sort of collision. But when I reached back out to the management at the collisions or at the rental agency, they told me they had one record of oil change service on this car in its lifetime. So at some point, this vehicle had some collision work done to it that the insurance or the rental agency did not know about. Pretty crazy. But here's some data that we collected. So with the bracket bent, with the bracket put back into following order, we're driving along, and we can see here's that relative speed. Okay, we have a plus and minus, so that's your Doppler, and then we have our distance. But you see how much there's some hash here. I found that should not be there. But look at how much hash is there when it's pointed in the wrong direction. A lot of hash. But this sensor, it got smacked at some point, and whenever they get smacked, it says right on the front of the sensor, do not drop, right? Right there, do not drop. So, these things are very, very sensitive. So they've been in a collision. They basically just need to be replaced. So you can put that vehicle back into order. We are at 15 minutes before class is going to end here. So let me see if there's anything else here that yeah, this last one was kind of a case study, and then so we're really towards the end here. So let me just go over this case study here real quick, and then we should be ready to roll with some questions here. So sometimes you're going to find some stupid stuff that happens. Here's a 2017 Honda that came in. The ACC and lane departure lights are illuminated, and there's messages that came up. It says adaptive cruise problem. It also said road departure mitigation problem. So we scan the vehicle, and we have one code. It says C0041, brake switch signal circuit error. It's permanent DTC. So my technician starts doing some research, and we look and we see that, walk through the thing. It says brake signal circuit error. We pull up the PIDs on the scan tool. The brake switch is working just perfectly. Everything's fine. There's actually a two-stage brake switch. One's normally open, one's normally closed, and they basically activate at different depths of pressure on the brake pedal. So we're going through on how to troubleshoot. What we did find is that there was a link to how these systems work, which was pretty cool, except it didn't really help us in this situation. But there's another great point of reference here on where it gives some good description on how these sensors actually operate. This is where I kind of got a clue. I go, well, okay, these work at different pressures, different steps along the brake application. And so what I asked I walked around the car with the technician and started looking, and what we found was that there was a cane in the right side of the right seat. And I looked at the car and I said, oh, is this an elderly gentleman that's driving it? And the next thing I looked at was the brake pedal. And some of you are probably going to know what I'm going to say here. The left side of the brake pedal had extreme wear. And I thought, okay, I'll bet you this guy's driving with 2 feet. And so what I instructed my technician to do is take the car and take the scan tool, take the car out, and I wanted him to lightly press on the brake pedal after he cleared the codes, lightly press on the brake pedal to set the first stage and take it out and drive it and see what happens. And he did, and it repeated the failure. So here, I won't play the video, but that is basically a case where the consumer was misbehaving with the vehicle, and so on. So last thing I want to close on, Diagnostic Network is a company that I started 2 years ago. We've got a partnership with AES Wave. You know, I'm doing some classes for them, but we do have a private group for their customers to collaborate with, and you know, they're providing instruction and training for folks that are buying ADAS equipment. So please, you know, contact them and talk to them if you're looking at providing some resources for your facility. So Rick, that's the end of my presentation.
Okay, we have a couple of things. There was some questions about the Jetson Nano. Where do they get it?
Okay, so the Jetson Nano, you can basically just go to Amazon, and I think it's like $100 or $200 or something. It's not very expensive. It will take you some time to get it set up. I am not a coder, and I was able to just follow the instructions. You'll need to get a GitHub account, but once you get this thing set up, it's pretty doggone cool. It runs on Ubuntu or a Linux, and basically you've got to, you know, set some certain things up. But this is what it looks like. Let me just pull up my camera. Am I sharing my screen still, or did you take it away?
No, I didn't take it away.
All right, so this is what this is the unit here. This is in a little case. I opted to buy this little case here, but you know, I bought the case with the fan, and then the camera was a separate thing. It's a 4K camera, but it has 4K output. It has a display port, HDMI, a bunch of USB, got an Ethernet port, and then it basically runs off this little micro SD card. That's what it boots off of, and this thing is super powerful. It's pretty cool.
There was a question: is can it see in the dark?
Yeah, so this is what sensor fusion is all about. At low light, that's where the high dynamic range comes in, but they have to have reliance on other inputs for the seeing in the dark or seeing it as extremely low light, such as the radar sensor, or this may be where it starts to get into the LiDAR type operation. But LiDAR, again, is a pretty expensive proposition, and you know, they can conclude with other instruments.
There's another question that says, is there a simple, effective way and system to aid students' understanding for a high school teacher on a tight budget for just a basic understanding of sensor, camera function, and calibration? You reference a couple of tools, systems. Can I get their names and a copy of your presentation?
Sure. Yeah, the presentation, there's a link to a Dropbox link. It's 400 megs. Everything's high resolution in there.
Yeah.
So that TI thing, the TI radar sensor, I believe that thing was $400. It basically runs in a web browser. It's a USB connection. You need to have a power supply for it. You know, I think it's 5 or 12 volt little connection. It's pretty inexpensive to get into that thing and rig up a demo.
And I think I've seen some experiments where they've been using the Jetson on like little electric cars, like, you know, like a robot kit or whatever.
Yeah, you can go nuts on this stuff. You can end up burning up a lot of time. There are guys building, so they're taking the results of that and they're actually going into robotics, right? And they're running a robotic operating system and interacting and making the car go. So, you know, in my opinion, if you have a deeper understanding of how these systems operate and what the computer's actually looking at and interpreting, then it helps you understand, you know, what's going on. If you look at these cameras, where these cameras are mounted up in the windshield, and say these cameras are in an environment like Arizona, what's going to happen to that camera after 10 years of extreme heat cycle? And you're tasked with doing a calibration, and it may not calibrate quite right. And why might that be? It could be because that camera lens has gotten distorted to the point where it won't reinitialize another calibration cycle. And so now you're making a call. on it, but having an understanding of what it's trying to do when it's doing a calibration, I think is helpful.
Yeah. For those that want, in the little side tab there, the toolbar that's on the side of the GoToWebinar, there's a one of the drop downs that says handouts, and that'll give you the link to the handout. Dan says there's lots of videos online and share tricks for setting up the Jetson Nano developer kit.
Yes. Yeah, all I did was follow the instructions, and it blew me away because I followed all the instructions, and when I hit the button to do my first experiment, everything worked, and I thought, oh my God, this never happens, right?
Yeah.
And it did. It was awesome.
Yeah. So yeah, it's really, it's a maker project is really what it is. You get in there and start playing, and you can come up with a lot of your own things too. So
yeah, and I think the student, young mind, if he starts to see that kind of stuff, it might intrigue him to to take on some other tasks or learn some other stuff. So it's going to be an interesting next decade looking at the automotive technology and systems that are being deployed.
yeah, and there was someone asking about if we could or if you could provide a parts list and basic how to set it up, but like I said, there's lots of them.
Yeah, there's lots of stuff. I will also mention, if you do I have a short video on YouTube that you can look at some more in depth of the radar and this camera setup that I did in my shop. If you do a Google search for CNN, so that's convolutional neural network NVIDIA ADAS, maybe just search by my name. You should be able to find it, but it's a pretty interesting video. I got a lot of really good feedback on that. In fact, I had an OEM reach out to me recently and said, hey, we're trying to teach radar and camera, and we came across your video. We want to know how we can do it. So that blew me away, but I think it's reaching some people, and they found some use out of it.
Yeah. And yeah, just another comment again that this really applies to STEM as well.
Yes, very much so.
Another comment again, you can have the class set it up. Maybe a shop could sponsor one kit per class per session. If I still owned a shop, I'd be willing to spend a few $100 each year to help support the program.
Yeah, actually, at the beginning of the year, see, I did that video. I started assembling this visual stuff right at the end of last year. And right after I did that, the high school I went to school at, which is like 5 miles from here, I know the auto shop instructor there, and I reached out to him. He saw the video. He said, "Oh my God, this is crazy." I was telling him, "Hey, I'd love to have field trips. We bring your students over. Let's show them some of this stuff." But then, unfortunately, COVID hit, and now we're kind of stalled out. But I thought, the same thing. You get shops to start setting some of this stuff up and start exploring, and it'll definitely broaden their minds and hopefully get them kicked off in the next phase of their lives.
Yeah. And well, it seems to be the end of it. So I'd like to thank you again very much. I'll turn it back over to Steve if he's got some final thoughts here too.
Yeah, again, on behalf of NACAT, thanks again, Scott. It was an awesome presentation. I want to thank everybody for attending. And remember, you will be getting a certificate. And we'd also like to remind you of the members meeting tomorrow morning, 11 o'clock Central Time. Thanks again, everybody. Have a great rest of the day.
Great. Thank you, guys. Appreciate that.